Well, welcome. I am Mr. Murphy, and in this particular video we're going to be looking at Power Standard skill number 20. And in this one we're going to be given a graph of a polynomial, and we're going to use that graph to determine what the zeros of that polynomial is. Well, there's going to be some terminology that we have to familiarize ourselves with, but first I'd like to look at some examples so you can see what we're working towards. In a little bit you'll be able to determine and answer this question where it asks you to find out what the zeros would be for that function that's being graphed. But first, let's make sure we understand this terminology of what is a zero and some other things that we're going to need to know in order to be able to answer this question. Now, the question first might arise is, well, what is a zero? Well, intercepts, roots, zeros, these are all terms that we could use to describe the same thing. In other words, a zero and a root is the same as finding out what the x-intercept would be for a graph. Because the reason for that, the reason why it's called a zero is because if you think about what a x-intercept is, it's where y is 0. So we're trying to figure out what answers for x would give me 0 as my solution for the equation. So that's one reason why we would call it a zero. But again, it could also be called a root, or it could also be called an x-intercept. And there's also this idea of, or this theorem called the number of roots of a polynomial equation theorem. It's a mouthful. But really, in reality, all this is just telling us that the degree of the polynomial is significant because that degree will tell us how many total roots there are. Now, the key is it tells us how many total roots. Now, some of those roots sometimes can be real numbers, and some of those roots can be non-real numbers where they wouldn't show up on a graph. There also could be what's called multiplicities, meaning we could have a root, a single root that has occurs more than once. And you'll see how that looks when we go to graph it. Let's take a look at this first example on the left here together, and same thing with the other one. That we'll look at these two examples on this page together, and then we'll look at that last one, and I'll have you do that one on your own. Let's first take a look at the one over on the left. It says the graph is of a polynomial function of degree 3. What are the zeros of the function? So the fact that it's a degree 3 tells us there's a total of 3 roots, and it just so happens that those 3 roots are all going to be real roots because we see that we have 3 distinct x-intercepts. So our roots here, or our zeros, would be at the coordinate -2, 0. Then we have another 0 at the coordinate 3, 0. And another one at the coordinate 5, 0. And if you notice with this next example, it says the graph is of a polynomial function of degree 4. What are the zeros of the function? Now if you notice with this one, we only have 3 x-intercepts, but yet it says it's a degree 4, which means we have a total of 4 roots. Well, one of these at -2, we call that a double root, because if you notice, the line does not go through that point. It touches that point, then it goes back up again. And so that we can describe as, like I said, a double root. So we would have our zeros here would be -2, 0. And we say that this has a multiplicity of 2. We got a multiplicity of 2 for that one, meaning that there's 2 of them at -2, 0. And then we have +1, 0, and +4, 0. So now if you count them up, with this one having a multiplicity of 2, then we'd have 3, 4, so a total of 4 roots there. So why don't you take a second and look at this one. So this one says a 4th degree polynomial function with the equation y equals g of x. We don't actually know the equation. And integer zeros is graphed at the right. List the 4 zeros. You want to make sure that you include multiplicities if they're already on this one. So why don't you pause the video and hit play when you're ready to check your answer. Okay, so you should have noticed that the x-intercepts, there's 3 x-intercepts. So that means, and if you look at this one here, that one doesn't go through that point, so that means it's got a multiplicity of 2. So my zeros would be coordinate -4, 0. negative 3, 0, and that one has a multiplicity of 2. And then we would have negative 1, 0 would be our fourth 0, or our fourth root. Well, there you have it. That's it. That is skill number 30. So hopefully after watching this video, you feel like you've mastered this concept of being able to find out what the zeros are and understanding that those terms, zeros, roots, all mean the same as x-intercepts. There really is no difference. But also to know that there are times where we do have multiplicities and that we do have, or that the degree of the polynomial tells us how many total roots or zeros there's going to be. So with that, good luck as you attempt some of these problems on your own.